potential difference. So if we increase the potential difference, the current flowing through the conductor also increases. So we can write this as V is directly proportional to R, or V is equals to, we remove a proportionality sign, that we have to write a constant. So I times constant, right? I times constant. So here is a constant. Okay. Now see, from this we can write V by I is always equals to constant, and we call this constant as R, which is known as resistance of the material. This proportionality constant is denoted by R and known as resistance of the material. So we can write V is equals to IR. V is equals to IR. So this is Ohm's law. Okay. So we write it equation number 1. Okay. So what does Ohm's law state? Suppose we have a conductor. Let us say this is our conductor, and there is an ammeter to measure the current. There is a key, there is a power source, that is battery, a rheostat to vary the potential difference, and a voltmeter to study the potential difference across the conductor. So this is our resistance R. This is potential difference measuring instrument called voltmeter, and this is ammeter, which is always connected in series. So here we see that when we close the key, when the key is closed, the current I starts flowing through this conductor, and the potential difference is measured by this voltmeter. The potential difference is measured by this voltmeter, and the current which is flowing in this circuit is measured by this ammeter. And here is a potential divider, we say it rheostat. Okay, so this is positive terminal, negative terminal, so V volt is applied from this source. So in this experimental setup, we can verify the Ohm's law. So one of the very most important thing is to note here is that the current is directly proportional to potential difference. The current is directly proportional to potential difference. What does it mean? It means that if the potential difference is doubled, then the current which is flowing through the conductor also get doubled. And if the potential difference which is applied across the conductor is halved, the current which is flowing through the conductor will also get halved. So this must be noted. So there is a proportionality between these two, which means that if potential difference is increasing, the current also increases, and if potential difference is decreasing, the current also decreases. Get it? Okay. Now here we have introduced one of the important terms, that is resistance. What is this R? This is resistance of the material. Here R is a proportionality constant known as resistance of conductor. So what is this resistance? So resistance is resistance of conductor. So what it is? See, we can say that whenever current flows through any conductor, current is flowing, it means that charges inside the conductor are flowing. So when the charges are flowing inside the conductor, they do not flow smoothly. There is some restrictions in their path. There is some obstructions in their path, and that obstructions is offered by material. So the obstruction, the opposition which is offered by material to the flow of electric current is termed as resistance. So resistance is basically opposition which is offered by any material to the flow of current. Okay, what is resistance? So resistance is the property of any conductor or material, by virtue of which it opposes the flow of electric current through it is called resistance of the material. So what is resistance? Basically it is the opposition to the flow of electric current. It is denoted by R. It is denoted by R. Okay, and what is its unit? So unit of resistance. So what is its unit? SI unit. What is its SI unit? So unit of resistance is unit of voltage divided by unit of current, because V by I is equals to R. So the unit of resistance can be calculated from this formula, unit of voltage upon unit of current. So what is unit of current and what is unit of voltage? So unit of voltage is volt and unit of current is ampere. So volt per ampere, VA power minus 1 is called unit of resistance, and we say it ohm. So volt per ampere is called ohm, and its symbol is omega. Its symbol is omega. So 1 ohm resistance is equals to 1 volt upon 1 ampere. 1 volt is resistance equal to 1 volt per ampere. So how we define 1 volt or 1 ohm? We define 1 ohm is the resistance which is offered by any material when the potential difference applied across it is of 1 volt and the current flowing through the conductor is of 1 ampere. So whenever 1 volt potential difference is applied across any conductor and the current flowing through is of 1 ampere, then the resistance offered by that material is said to be 1 ohm. So I will write it for you. So 1 ohm, when the potential difference applied across the ends of conductor is 1 volt and current flowing through it is of 1 ampere, then the opposition offered by material is 1 ohm. Okay, so whenever 1 volt potential difference is applied across the ends of conductor, and if the current flowing through the conductor is 1 ampere, then the resistance of that material is said to be 1 ohm. Okay, got it? So what is 1 ohm? 1 ohm is the resistance of any material which is offered when 1 volt potential difference is applied across the conductor and 1 ampere current is flowing through it. Okay. So this resistance plays very important role in our electric circuit. So what are the factors in which this resistance depends? How we can say that the resistance of any conductor is increased or decreased, whether it depends on temperature, it depends on any other factors or not. So the factors which are affecting resistance, factors which are affecting resistance are length of the conductor, How resistance depends on the length of conductor? So it is found experimentally that the length of conductor is directly proportional to the resistance. So resistance varies linearly with the length of conductor. So if we increase the length, the resistance of conductor increases. If we decrease the length, the resistance of conductor decreases. So the resistance of conductor, that is resistance of conductor, is directly proportional to L. So if L increases, R increases. If L decreases, R decreases. Another factor which affects resistance is area of cross section. Area of cross section. So area of cross section. How resistance depends on area? So it is found that resistance of conductor is inversely proportional to its area. So R is inversely proportional to its area. It means that if we increase the area, resistance decreases. If we decrease the area, resistance increases. So combining these two equations, we get, combining A and B, R is directly proportional to L by A. It implies R is equals to rho L by A. So what is rho here? Rho is another constant which is known as specific resistance of the material, or we say it resistivity of the material. Got it? Is it clear? On two factors, one is length of conductor, another is area of cross section. Does any another factor is there which can affect resistance? Answer is yes. There are two more factors which can affect resistance of the material. What are those factors? Those factors are temperature of conductor. Temperature of conductor. Another factor is nature of material. Nature of conductor. Nature of conductor material. Okay. So basically we can say that there are four factors which affect resistance. One is length of the conductor, another is temperature of the conductor, another is nature of the material of conductor, another is area of cross section. So resistance depends on these four factors. Got it?